Okay, I'm going to be talking about our basic trigonometric functions here, and how to determine the ratio of those, those functions. So trigonometry is going to be the study of the relationship between the sides and the angles of a triangle. Specifically, we're going to be looking at right triangles. So when we're looking at right triangles, it's really important that we talk about three vocabulary words. The hypotenuse, we've already talked about. So the hypotenuse is always the side directly across from the right angles. Now these should have right angles in them in the corner. So I'm going to add those there. Please make sure you add them on your notes if they're not already there. All right, so the hypotenuse is always directly across from that right angle every time. So we're going to label the hypotenuse with the letter H. All right, so my hypotenuse again is always the one directly across from our right triangle, our right angle. All right, then we've got the opposite. Now the opposite is going to depend on the angle given. So I'm going to put a little theta down at my base of my triangle for this one. And then I'm going to put the theta up here. So again, it's always dependent on the angle that you're looking for. So the one that is opposite, we're going to label with an O, is always directly across from the angle given to us, or the relationship we're trying to find. So on these triangles, the O is different. Again, it's across from the angle we're trying to find. And then the last piece here is going to be adjacent. Adjacent is next to the angle that's given. So it's the piece that's touching the angle that we're creating. So here, notice that directly next to it, we're going to put for adjacent. Directly next to the angle. I like to think about it too as it being between the two angles. So the angle we're trying to find, or the angle we're given, and the right angle, that side is always going to be our adjacent side. Highlighting and using pretty colors is very helpful in this. All right, so let's take a look. We're just going to label these sides based off of the given angle. I always start with my hypotenuse because I think that's the easiest piece for me to find. Directly across from my right angle always goes my hypotenuse. And then I'm going to flip-flop, and I'm actually going to go and do my A next because I think that's the second piece that's easiest for me to find. The side that's between my given angles. So I've got the given angle and my right angle right here. So the side that's touching both of those, that gets my A. And the last piece is the opposite, which is always across from the given angle, and that would get my O. All right, let's try it again. Across from the right angle, I'm going to put my H. Between the given angle and the right angle, so the side that touches both of those, is my A. And directly across from the given angle is our O. We're going to try it one more time together, and I'm going to have you try that third one there on your own. So directly across from the right angle gets my H. Between my given angle and my right angle goes my A. And across from the given angle is our O. All right, I'd like you to pause the video, try to do this last one on your own, and then unpause and check your answers with the ones that I'm about to put on the board. All right, so you should have gotten that over there on the right-hand side when you tried. If you have further questions, make sure you ask them in class. Now we're going to talk about how that relates specifically to our trigonometric functions. So there are three that we're going to talk about. We are going to talk about sine, cosine, and tangent. And we're specifically going to talk about the ratios of those sides. So if I fill out my triangle over here based off of this being my theta and my right angle, I've got my hypotenuse, got my adjacent, and I've got my opposite. All right, so when we're talking about sine, cosine, and tangent, they're going to use all of these relationships. So sine is going to be the opposite over the hypotenuse. O or O over H. Cosine is going to be adjacent over the hypotenuse. Or with our abbreviations, A over H. And tangent is going to be opposite over adjacent. Or O over A. Now there are lots of mnemonics to help you remember what this could be. I just personally remember SOHCAHTOA. Okay, and I think about it like an Indian princess, but I always write SOHCAHTOA in a very special manner. So I write S for sine is opposite over hypotenuse. And then I write C for cosine is adjacent over hypotenuse. And then finally, T is O over A for tangent, which is opposite over adjacent. So SOHCAHTOA. Now there are lots of mnemonics. I'll say a few in class to give you ideas, and if you want to look them up, you can. But you do have to have SOHCAHTOA memorized. You have to know it. I strongly suggest writing this on your paper every single time, just so that you memorize it. Here we're asked for the trig ratios based off of the given angle. So the first one, they're asking us about angle A. So I'm going to mark angle A here as my theta, and I'm going to label my triangle based off of that angle. All right, so across from the right angle is always the hypotenuse. Between the given angle, so between theta and the right angle is our adjacent. And across from our given angle is our opposite. Now again, I'm going to write SOHCAHTOA on my paper. S is O over H. Ka is C O A over H. And TOA is T is O over A. All right, so they're asking me about sine. So I'm doing my O, which was 5, over my hypotenuse, which is 13. And that is the relationships of my sines. It doesn't simplify any further. Okay, and you can check that by typing that into Desmos. So we're going to type in 5 over 13. And then you just hit the little fraction on the side and it still gives us 5 over 13. If it simplified further, it will give us a different number in the fraction. For example, 2 divided by 4. If we click on that, it'll simplify it for us. All right. And then my next one, I've got A over H. So A was 12 and h was 13. That one doesn't simplify any further as well. And then the last one, we've got tangent, which is O over A, so 5 over 13. All right, now we want to do it based off of B. So I'm going to erase my markings, and I'm going to change where my theta is. And then I'm going to mark it again. So across from my right angle is always H. Between the given angle and my right angle is A. And across from the given angle is O. All right, so sine is O over H. So 12 over 13. Cosine is A over H. So my A was 5, my H is 13. Tangent is O over A, so 12 over 5. All right, we've got one more example to check out here. Again, I'm going to rewrite SOHCAHTOA because that's what I'm going to need. So is O over H. Ka is C for A over H. And TOA is T, and it's O over A. All right, now we're going to fill out our triangle based off of theta being A. So across from the right angle is H. Between the given angle and the right angle is A. And across from our given angle is O. All right, so sine is going to be O over H, or 1 over 2. Cosine is going to be A over H, or the square root of 3 over 2. And tangent is going to be O over A. So 1 over the square root of 3 over, 1 over the square root of 3. Now, most of the time, we cannot leave radicals in the denominator, but in this class, you are more than welcome to leave them there. I would like you to try the second one there on your own and check to see that you get the answers that I get. So please pause this video, rework the picture, and see what you get.